Okay guys, I'm writing down the key for you, okay? So once you're done, you can check with the key, okay? Alright, so let me write it this way. I skipped some step, but eventually the answer is given, okay? If I do something wrong, let me know. I sometimes do something wrong, okay?
Oh, yours doesn't. Yeah, I just crossed everything. That's a lot of calculation, okay? The number 4. Okay, so we have 15A squared. This is positive. Okay.
E plus H.
Yeah, so it's like, I know how to do it, it's just now instead of fire protection.
So you're still looking at the experiment? So that all
Or does it matter? It's all addition. Right. As long as you have to make it back again. Yeah.
Especially number 4 to 5. Number 4, a lot of students confused about, what is f of a bracket square? So we do it from what? We start from f of a, right? So f of a is when x equals a, give us 3a squared plus 6a minus 5. Square of it means what? We multiply it, right? We multiply it up. And then this is a 3, terms times by 3 terms. So we do what? We do use the idea of FOIL, right? So we use 3a squared times by each term from the second parenthesis, and then we get 6a times each term from the second parenthesis, and then we use negative 5, distribute to the, second parenthesis each term. So eventually, do you get the same answer with me or different?
I have the same.
You good? Okay, good. I sometimes did something wrong. Okay, if I make something, make mistake, let me know, okay? The last one is f of a plus h means we have to replace x by what? A plus h, right? And this square, okay, we use a formula, give us what? A squared plus 2ah plus h squared. And then this x, we replace it by a plus h. We have to distribute the 6, give us 6a plus 6h. And then we can get a 3a squared plus 6ah plus 3h squared plus 6a plus 6h minus 5. There's no like term, so this will be our final line. Do you get the same answer as well, everybody? Okay, good. Okay, alright, so this example is a very good example, okay, that's a good question, okay, so similar question, you can, pay attention, right? Alright, so let's move on to look at more practice questions, okay? We only have another 25 minutes, so for the rest of the questions, okay, they are similar questions. So I'll show you one question, and I'll give you the key for the other, so you can finish up the other question and then check with the key, okay? And if you still have questions with, questions, okay, let me know next time, okay? So, this example is to evaluate the difference quotient for the given function. Simplify your answer. We have two problems. You pick one, and then we do it in class together, and then the other one, you do it by yourself.
I prefer number 2.
Number 2?
Yeah.
Everybody go with number 2?
Yeah, we'll do number 2.
Okay, so let me first give you the key for question A, okay? The answer for question A is eventually after we simplify it equals, let me tell you the answer first, okay? It equals 3a squared plus 3ah plus h squared. This is the answer. I want you to do it after class by yourself, okay? Alright, number 2. If f of x equals 1 over x, simplify this expression. How? How, guys? Just plug in, right? Plug in f of x. What is f of x? 1 over x, right? Minus f of a. What is f of a? When x equals a, we have 1 over a, right? And on the bottom we have what? X minus a, right? Okay. So, are we able to simplify 1 over x minus 1 over a divided by x minus a? How? See, on the top, right? On the numerator, we have two fractions. So for fraction subtraction, how can we combine them up? Are they having the same denominator? No. So in order to combine fractions, adding or subtracting fractions, we have to make sure we find at least the common denominator, right? So one denominator is x, the other one is a, so what is the LCD? X times a, right? So what we do is, we times a to the both top and the bottoms of the first fraction, we make it to be a times x or x times a, it doesn't matter. For the second fraction, we need to have the LCD AX. How? By multiply both top and bottom by what? X, right? So x, 1 times x is what? X. You guys, can you follow me? This is a key step, okay? Now, are we able to combine the numerator to the two terms? Yes, we are. AX is a common denominator. We have a minus x, right? On the bottom we have what? X minus a. Can we say this is a most simplified version form line? Yes or no? No, why not? You see, we have a minus x. We have x minus a. What's the difference between a minus x and x minus a?
Let's say one reverse of each other.
Yeah, what is 5 and negative 5? They're additive reverse, right? How do we call that? Okay, like it's not reciprocal. Reciprocal is for multiplication. Yeah, it's called additive inverse. Additive inverse means 5 negative 5. The sum of the two numbers equals 0. So a minus x, we could rewrite it as what, guys? Negative of x minus a. What do you think? Can we? And then divide by a times x, and then divide by what? X minus a. Can we keep on simplifying this? Okay. A fraction divided by something means what? Multiply with something reciprocal, right? Or, well, let me write it this way, okay? So this negative x minus a divided by a times x, this is a fraction, this is a numerator, okay? Numerator of the fraction. Divided by x minus a is the same thing as multiplied by what? 1 over x minus a, right? Divided by 5 is the same thing as multiplied by 1 over 5, right? So, can we cancel out this x minus a? Yes or no? Yes. Well, if, okay, we should say here, if x minus a does not equal 0, means what? Oh, x minus a is a non-zero number, because if x minus a equals 0, 0 over 0, we're not able to cancel that out. We have to make sure x cannot be a, or x minus a cannot be 0. Then we could cancel out the x minus a, so it gives us 1 times y is 1, ax times y is ax. So answer is 1 over what? A times x. This is the final line.
I have a question.
Sure.
You say you gotta show work on test, you use partial credit?
Yeah. You mean the question on the exam, right? If you get something wrong, but not completely wrong, but partially right, of course. As long as you put your work on it. If you just give me the answer in the exam, if your answer is wrong, you lose all of the credit. But if you show me the work and then process about how to work on, a final, answer, even if you get some part wrong, you still get partial credit. That's. Okay, so this is this type of example. Simplification. Can we move on, guys? Okay. All right. This type of example finds the domain of the function. Also very good type of the exam problem. Okay. I may give you some functions and let you find the domain of the function. Okay. Well, mostly there are two types of functions we have to pay attention to. One type of function is what? It's in the form of what? A fraction. If we have the function is defined in the form of fraction, we have to make sure that what? The denominator cannot be what? 0. Okay? So to find the domain of this function, what should we do, guys? We are going to find the x values that will make the denominator equal 0 and get rid of them. So we can find our domain, right? So what we can do is to let what? X squared minus x equals 0, solve for the x values, okay? And those x values will actually make the denominator equal 0. So our, final, we want to do what? Eventually, get rid of those x values, right? So how to solve for x squared minus x equals 0? How? Factor the x out. So this is x times x minus y equals 0. And then how many x values can we solve for? If a multiplication equals 0, either of the factors should be 0. So either x equals 0 or what? X minus 1 equals 0. And then that gives us x equals what? 1. Right, guys? Okay, so this is actually solved for quadratic gradient. You learned this from the college algebra, okay? Alright, so now we find two values of x that make the denominator equal 0. So, what is the domain, guys? Domain will be, we can use a set Bueller notation, or you can use other expression to define, describe this domain. Domain will be all of the x such that x cannot be 0 and at the same time x cannot be 1. Okay? Yeah, we solve for the values that makes the denominator equal 0, but we cannot use those x, right? We have to get rid of them. So we let the denominator equal 0, and then we get rid of those x values. Any question about this problem? No? Okay. Next question. I will give you a little bit of hint and give you the answer, okay? This one is even more challenging than the first one. So I just said there are mostly two cases. Okay, we have to pay attention. The one case is what? When the function is defined by what? In the form of a fraction. What's the second case? Square roots. Okay, if we have a function is defined by what? Square root of something, or fourth root of something, or sixth root of something, under an even number of the index of a radical expression. Under the radical expression, we have to make sure that part is what? Greater than or equals what? 0. Right? Square root of 0 is 0, fine. But square root of -5, we're not able to do it in a real number system, right? No. Now for this problem, look at it. We have a 1 over 4th root of x squared minus 5x. So we have a radical, right? It's a radical. Well, this function, 1 over something, this is also in the form of what? Fraction. So it's a double layer, right? So they're like a double of them, right? So how can we deal with this problem? So first, as a fraction, denominator cannot be 0, right? So that means our x squared minus 5x cannot be 0, right? As a denominator. Then, fourth root of x squared minus 5x. We know under the radical expression, the x squared minus 5x should be greater than or equal what? 0. Should be greater than or equal 0. However, x squared minus 5x under the radical expression should be greater than or equal 0. However, it's also on the denominator. Can we choose the equal to 0 case, yes or no? No. So actually for this problem, okay, how to find the domain of the function is we only need to solve for an inequality. What inequality? X squared minus 5x strictly greater than what? 0. Then it will give us the domain of the function, right? Oh, the thing is, do you still remember how we solve for the x squared minus 5x greater than 0? Do you know how to solve for it? Yeah, see? Yeah, see? We found that, we need to solve for the inequality, but I think some of you guys have already forget about how to solve it. How, guys? We can factor that, right? We can factor that. And then x times by x minus 5 greater than 0, okay? So we have two factors, okay? Each factor gives us what? An x value, okay? So from x times this, x equals 0, x minus 5 equals 0 give us x equals 5. These are our key points, okay? They are not a solution for the inequality. However, we can use these not key number, these are the critical number, okay? Critical number to divide the real number line into what? Let x times x minus 5 equals 0. We can solve for two critical numbers. So it will divide the real number line into 3 intervals, right? Remember? What are 3 intervals? Negative infinity to 0, 0 to 5, and 5 to what? Infinity. Remember this? Okay. Well, so on which interval it will make this x times by x minus 5 greater than 0? What do we do, guys? Choose key point. On this interval, we choose key point -1. Let's plug in x by -1 into this inequality and see whether this inequality is true or false. So when x equals -1, guys, -1 minus 5, -6, right? -6 times -1, is it positive or negative? Positive. So can we choose this entire interval, yes or no? Yes. If one key point works, entire interval will work, okay? So, we know on this entire interval, negative infinity to 0, every real number on this interval will make this inequality satisfied. So this is part of our solution. Can we choose this interval? Let's see. When x equals 1, 1 minus 5, negative 4 times 1, is a product positive? No. Yeah, or no? No, okay? So, no, we cannot choose this interval. How about this interval, 5 to infinity? Choose when x equals 6. Try. 6 and 6. 6 minus 5, positive. 6 times positive. Positive. So, what is the answer for this question? What is the domain for this function, guys?
Negative infinity to 0, you mean what?
5 to infinity. This is hard. That's not easy, okay? So this is not just a hint, it's an entire solution. Alright, we have 10 more minutes of the class, okay? So I hope we can finish section 1-1 at least, okay? So, this vertical line test, I don't have time to let you guys read it, okay? I will read it for you, okay? A curve in the xy plane is a graph of a function, even only if no vertical line intersects the curve more than once. What does this test tell us? If every time we use any arbitrary vertical line, we vertically intersect the graph, every time we'll have what? At most one intersection. Then this curve is a graph of what? A function. Now how about this second case, this case D?
Do you think this curve gave us a graph for a function?
Yes or no? No, because we use a vertical line and then it has what? Two intersections, right? Why? Because one x value can only correspond to one y value, but this one, it gives us two y values, corresponds to one x value. So it's not, okay? It's not. So you know this, okay? So you know this test. All right. Piecewise defined function, okay? Let's do one. I'll give you the key for the other. What kind of function is called a piecewise defined function, guys? You see, this type of function, there are how many pieces of it? Two pieces, or two equations, right? There are two equations of it. So they're called piecewise defined functions. Also, same thing for this function. Oh, I missed an f, okay? So other notes, please add this f. This is f of x equals, when absolute value of x is less than or equals 1, it equals absolute value of x. X is greater than 1, just greater than 1, y equals 1. Let me give you the key for this second piecewise defined function, and I'll show you, I'll show you how to do A, okay? How to do A.
Two pieces. Okay, the first piece is f of x equals absolute value of x. When x is between what? Negative 1 and 1.
Why? Because absolute value of x is less than or equals 1. It gives us x varies between negative 1 and 1. Because all of these x values between negative 1 and 1 satisfy the absolute value of it is less than or equals 1. That makes sense, right? So this is the first piece, okay, first piece.
So when x is between negative 1 and 1.
Do you know how to graph an absolute value function?
You still remember the shape of it? Looks like this, right? Okay, so it looks like that. Oh yeah, it looks like a V, right? Okay, so within negative 1
and 1, okay, we have a V-shaped function, absolute value function. And then the other piece is when x is greater than 1, y equals 1.
Okay, so f of x equals 1 when x is greater than 1. So,
y equals 1, what kind of function it is? Constant function, right? Y equals a constant, right? So means it's going to be what? Horizontal line, right? Horizontal line. Well, x is greater than 1.
well, we can draw a, open circle and then always goes here, right? However, because this is a closed circle, so we don't have to make it a, so actually this is a closed point here, okay? Because
Yeah, you mean if we don't have a closed point when x equals for this piece, but from the first piece when x equals 1, y equals 1. Okay, so this is a graph for the second piecewise defined function, you guys. So how to graph a piecewise defined function, guys? It's pretty straightforward, and then, or you can call it tedious, whatever you call it. It's like what? Piece by piece. You graph the piecewise defined function piece by piece. Oh, what is the first piece? Graph it. What is the second piece? Graph it separately. Well, respectively, not separately. Okay? But eventually we have to combine them. So, what is the domain and range? Oh, what is the domain, right? It's just ask for domain. What is the domain for this function?
in the x direction, x varies between what? From where to where?
-1 to infinity.
Yes.
Domain is from -1 to infinity. Very good. Okay. Alright, so what's up?
Can't x also be -2?
Can also be -2. Well, I'm not sure whether this is a completed question. So it may have another pieces when x is less than -1. F of x is something else, but I don't know. So, but this question so far by the given two pieces, this is already the whole picture. Okay.
It's because it says if the absolute value of x is less than 1.
Oh, yeah, you're right. Why I'm missing an absolute value? So you're right. This should be an absolute value of x. I should fix my notes. Yeah.
No, it shouldn't.
Did I copy this question somewhere from the book something?
It's perfect how it was.
Yeah, well, yes, yeah. Okay, so according to what is given, this is done. If we add the x value, we have to add a third piece, right? So third piece is x is less than -1, we have the other branch, okay? But just let's, leave it here, because this is whatever it is given, okay? Yeah.
Can you do the first question?
Yeah, first question. Okay. How to sketch the graph of this function? Now, as we have already discussed, so we have to do it piece by piece, right? So what is the first piece, guys?
3 minus 1/2 x, if x is what? Less than or equals 2. So, how to graph it? We can use chart, right? X, what is y value? 3 minus 1/2 x. This is when x is what? Less than or equals 2. That means we can only choose
X is what? 2 and even lesser, right? So we can choose x equals 2, can choose x equals 1, 0, and -1. We can choose this, okay? We can choose something else, okay? So when x equals 2, what is y value? 1/2 times 2 is 1, 3 minus 1 is what? 2, yes.
Very good. So let's draw the picture. So let's mark it 1, 2, 0, 1 and 2, 1 and 2. So 2, 2. Well, can we
Use a closed circle for this point, 2, 2, yes or no? Yes, because we may choose x equals 2, yes. So we are going to use a closed circle, okay, closed point here, okay, a solid point here. So when x equals 1, we don't like this, okay, we can skip that. Why? Because if x equals 1, we'll have a 1/2, 3 minus 1/2, we will have a 2.5, right? But that's also fine, okay? We can use when x equals 0, right? So y is what? 3? So 0, 3.
You don't have to draw too many key points because
Y equals 3 minus 1/2 x is a straight line, right? For a straight line, how many points become a straight line? 2. Okay. Yeah, see? We have a 0, 3, we have a 2, 2, so this is already good enough, right?
Alright, so let's draw the line. You can use a ruler.
Okay, well here I'm just use my piece of paper and make sure that the x value is what? Less than or equals 2. Okay, so we're not going to extend our line in this direction because x is bounded, okay? X has to be less than or equals 2. Right, guys? Alright, this is the first piece. What is the second piece? F of x equals what? 2x minus 5.
Well, x is what? Greater than 2, right? So we can also make a chart. X value, y value equals 2x minus 5. X is greater than 2, right? Okay, so what x value can we choose?
Can we choose x equals 2? Well, technically we cannot choose x equals 2, but we would like to know when x is very close to 2, what is the y value? So let's still choose it. When x equals 2, what is the y value? Negative 1. So 2, negative 1. Where's 2, negative 1? 2, negative 1 is here. But for this point, can we use a solid bit?
You open, right?
Yeah. We have to leave it open, okay, because x cannot be 2. Then x has to be greater than 2, right? So what do? Can we choose x equals 3?
Yeah.
And see whether we like this x value. And then 2 times 3 is 6. 6 minus 5 is what? 1. 3, 1. 3 and positive 1 is here, which is this point, right? 2 points determine a straight line, right? Okay. Alright, so this is another piece of the graph, right? Okay, so this is a graph for the function. What is the domain for this function, guys? What is the domain?
Negative infinity.
Yes. Oh, it looks like we have a hole here. However, when x is equals 2, can we say yes?
Because for x, it says x is less than or equals 2, 2 is included. Well, even if this piece, we don't have a 2, but together we have an entire
Real number, yes. So domain is what?
from negative infinity to positive infinity, okay? Alright, the last part is some definitions about even or odd functions, increasing, decreasing. Please read these definitions by yourself, okay? There's no practice question about this part, so just read them by yourself, okay? Okay, so today we finish up learning section 1.1. Please go home, do those questions, the first 10 problem from section 1.1. Wednesday, we'll do both sections. We'll do section 1.3 and 1.4. We'll finish up 2 sections, okay? Alright guys, that's for today. If you have any questions, let me know, okay?